Hello everyone, welcome back to my channel. So in this video we are going to study class 8th chapter class 8th chapter number 11 11, that is chemical effects of electric current. So in this video we are going to finish this entire chapter in one shot. So let us begin. So let us begin with our chapter. So the first topic of our chapter is, it's not in the NCERT, but still I am going to teach you because it's a foundation and it will also help you in ninth class, that is charge. Firstly we are going to understand what is charge. A charge is nothing, is a property of metal, is a property of metal, not matter. Charge is a physical property of a matter which make it experience a force when it is placed near a magnetic field. For example, here is a magnet. So the magnetic field that is produced by this magnet will experience a force, and that force will call charge, and that force will call charge. So charge charge the unit of charge is coulomb. The unit of charge is coulomb, and its symbol of representation is Q. I hope you understand till here. Now we are going to understand next thing in our chapter, that is what is electric current. Electric current is the flow of charges, that is mainly electrons, in a through a conductor is called electric current. The flow of electrons in a conductor is called electric current. The flow of electrons means, for example, here is a cell switch and we are flowing through what liquid. Okay, so here the flow of electrons in this circuit, the flow of electrons from the conductor. What is conductor here? This liquid, it is vinegar, so we can write it as vinegar. The flow of electrons from this conductor is called electric current. Electric current comprises of charges, the flow of charges, and charges are positive charge or negative charge. In electricity, negative charge will flow, that is electrons are having negative charge. So the unit, first we write the symbol of electric current is I. Its its unit is ampere. Ampere. And its formula is I is equals to q upon t. Here I stands for electric current, q stands for charge, and t stands for time taken. So from here we can also derive the unit of what electric current, that is I is equals to q, and q is charge. Charge unit is coulomb, that is c, upon time taken is t. So it is called ampere. It is derived from a name of scientist. And one more thing, that electric current flows from positive terminal to negative terminal. Means for example, it is a circuit switch. It is called closed switch and this is open switch. Means from this switch the current will flow, not from this. We can close the circuit. Electric current will flow from positive terminal to negative terminal. So electric current will flow from here, not from negative. But the flow of charges is from negative to positive. You have to learn this and remember that electric current flows from positive to negative, but the flow of charges is from negative to positive. Now I will understand your concept of class 11th, that why the flow of charges is from negative to positive. Because charges are electrons. The thing we learned that electric current flows from positive terminal to negative terminal is scientifically wrong. So why we are studying this? We are studying because electric current was discovered very earlier. So, and we have found many new concepts related to the electric current, that it flows from positive to negative terminal. But after few years ago we found electron. Now a scientist said that really the electric current flows from negative to positive. But we have found many concepts related to this. So he said that not to change this concept, but instead we can say that charges flows from negative to positive terminal. I hope you have understand this. So now we are going to study what is the heading of our chapter. The heading of our chapter is chemical effects of electric current. We have studied about electric current till now. We have studied what is electric current, the flow of electrons. But chemical effects, what does chemical effects mean? Understand the text. Chemical effects of electric current means when we pass electricity through a conductor, it shows some chemical effects within it. Understand, when we pass electricity from a conductor, it shows chemical effects, chemical changes in its property. For example, when we pass electricity through a liquid, it may changes its color, or it may form a residue. So these are called chemical effects of electric current. There are three effects of electric current. First one is magnetic effect, heating effect, and third one is chemical effects. All three in a definition we can say that when electricity is passed through a conductor, it shows some magnetic changes within it. When electricity is passed through a conductor, it shows some heating effects in it. When a electric current is passed through a conductor, it shows some chemical changes within it. Magnetic effects example, we can say electric bell or fridge uses the principle of magnetic effects of electric current. And heating effects, toaster, electric heater uses the principle of heating effect of electric current. And in this chapter we are going to learn about chemical effects. It's an intro of the chapter. So now we will start beginning our chapter. Now from the basics I am going to tell you. I hope you know what are conductors and what are insulators. The substance which conducts electricity is called conductors. The substance which do not don't conduct electricity are known as insulators. Example of conductor is, but in the case of electricity, maybe according to the NCERT, it's not proper to categorize materials into conductors and insulators, because every substance conducts electricity. So insulators is a term which means anything, it doesn't contain anything. So we can categorize, it can be come in your paper that why it is not good to categorize materials that conduct electricity into conductors and insulators. So we can say that examples of good conductors and example of poor conductors conduct some electricity. Example of good conductors, you can say silver, copper, aluminium and gold. These four are good conductors of electricity. Even water, and water that is pure water, no, salty water, and you can say vinegar, other things. Poor conductor are air in terms of gases, distilled water. Distilled water means the water, wait, the water which we obtain from the process of distillation is called distilled water. It doesn't contain any impurities, so it is also a poor conductor of electricity. And other thing is in the terms of solids. In terms of solids, mostly all non-metals are poor conductor of electricity. But we can say rubber, plastic, glass. These are poor conductors of electricity. Now we have to understand what are electrolytes. Electrolytes. What are electrolytes? Electrolytes are the conducting liquids. One line definition: conducting liquids means any liquid which conduct electricity. Any liquid which conduct electricity is called electrolytes. For example, we have made a circuit. So here is a it is a cell switch, and this liquid is called electrolyte. Whether it is water, vinegar, lemon juice, you don't have to understand it. Any liquid which conduct electricity is called electrolyte. It's called electrolyte. Now, a thing which may be coming in your mind is, which liquid conduct electricity? Which liquids conduct electricity? The simplest answer is acids. No, first I am going to explain you the concept, then we can. Wait a minute. The liquids which form ions conduct electricity. Now you may be thinking that what are ions? Ions are charged atoms. The atoms that are charged, that are having charge, are called ions. And which atoms are having charge? The electrons and the protons. Ions are the charged atoms. Ions are of two types, cation and anion. Cation means negative, anion means positive. The atoms which are electrically, we can also say that the atoms which are electrically charged are called ions. So now understand the definition. The liquid which form ions conduct electricity. And so, which liquid form ions, and why liquid form ions? The liquid which form ions, and how ions are formed in a liquid. Acids, base, and salts. When dissolved in a poor conductor form ions which conduct electricity. If there is any liquid in the universe which doesn't contain which is poor conductor of electricity, if you are going to add some acids or some base or some salts in that liquid, it will produce ions. And those liquids which produce ions conduct electricity. So what we studied, that which liquids conduct electricity, the liquids which have ions conducts electricity. And how are ions formed? Ions are formed by the mixing of acids, base or salts. Now when I'm explaining you other topics, I give the example of salty water, vinegar, because vinegar is acid, and we know that all acid, base, and salt conduct electricity. If we are going to take distilled water, I said distilled water, and why distilled water doesn't contain electricity? Because it is the purest form of water. Purest. It doesn't contain any salts. If there is no salts, means this condition doesn't satisfy. To make a liquid conducting, it must be salt, or it must be acid, or it must be base. But distilled water is the purest form of water. It doesn't contain any minerals or any substance. So we are going to mix some salt in it. Salt. Now it will conduct electricity. So this concept is cleared. Now in your book, in NCRT, there is a term called tester. Tester. What is tester? Tester is nothing, but it is just a part of, or a piece of electrical equipment that is used to check the substances, whether it conducts electricity. So what is tester? A tester is a circuit or a part of electrical equipment, means no, we can. So if we want to check that any substance is conducting, any liquid is conducting electricity, so we use tester. A tester is a formation of a battery or a cell, a battery, and a bulb. And here we place any material. Firstly, we will place a battery. Then a bulb, and then a metal or any matter which we want to check whether it is conducting electricity or not. Now, when we will join it, if the bulb will glow, means the substance is conducting electricity. If the bulb doesn't glow, means the substance doesn't contain electricity. For example, if we place here distilled water, the bulb will not glow, means it shows that distilled water is a poor conductor of electricity. If here instead we put silver, we put a silver bar, then the bulb will glow. It shows that silver is a good conductor of electricity. In your exam, a question can come: how to check whether a substance conducts electricity. So here it can be two answers. First answer is of basic level, means of 8th class level, that is by checking it to tester. If we, it is a process, but do you think why silver conducts electricity but doesn't wood? Why gold conducts electricity? Why copper conducts electricity? Because of a term named free electrons. Free electrons. Free electrons. A substance. I will draw a diagram. For example, it is a silver. It contains electrons. The substance which contains free electrons means inside a substance, if the electrons are having enough space to move, means they are free. It is called, means the substance electrons are having enough space to move will conduct electricity. Free electrons means the flowage of electron is free. In case of rubber is not having free electrons, so it doesn't conduct electricity. So this concept is cleared. Now we will moving forward to experiment. Experiments that shows heating effects of electric current. Heating effects of electric current. What do you mean by heat? Means when we pass electricity through a conductor, it will show some changes in heat. Means it can increase the heat. It can pass sudden heat through the substance. Heating effects, I will explain you. In heaters, when we pass electricity through, you have seen this where we will place the charger. When we pass electricity through it, most of us are having this rod heater. When we will switch on, then this electricity will pass through this heater, then it will show heating effects. Means when we will pass electricity through a substance, through a conductor, it may show heating effects in the substance. When we will switch on it, it will show some heating effects in the heater, the increase in the temperature and the change in the color. Now through circuit I will explain you an experiment that is given in your textbook. Here is a battery is a bulb, so another thing that I want to explain you, that these two rods which are dissolved in this liquid, these two rods are called electrodes. These two rods are called electrodes which are dissolved in this liquid. So I will explain you it later with more description. So when we will switch on, I will make a switch. When we will switch on this circuit, then the electricity, what I had earlier told you, that electricity flows from positive terminal to negative terminal. When we will switch on it, here the electricity flows here. Now here we see that these two rods are not joined, means the circuit is open. Then how can electricity flow? The main concept is that if the circuit will not open, if the circuit is open, for example here the circuit is open, means the electricity will not flow. But I will explain you, when this rod get dissolved in this liquid, the positive charge, wait, I will not explain it because it's too high level, but still roughly I will give you an idea that when this rod comes in this liquid's electrons get attached with the electrons of this protons of this rod, and then electron proton minus plus minus, then this will go into this rod, then it will flow here. But this is not in your textbook, so we will understand from your textbook. When we will switch on the circuit, the electricity will flow from here, then it will flow into the liquid, then the liquid will pass the atoms from this positive rod to negative rod, and it will flow from here and the bulb will glow. This proves, we can consider it as vinegar. This proves the heating effects of electric current. When we pass electricity, the heat is produced in the bulb. It is heating effects of electric current. Heating effect means the change in the heat means temperature increment. When we will pass electricity through a conductor, it will show heating effects. Just this much. Now I said you about electrodes. Electrodes are the rods which is dissolved in conductors, in what we can call that electrolytes. For example, the rod which is I will explain you that this bigger one side is positive and this smaller one is negative. So positive here, positive, negative here, negative. The positive side, the positive electrode is known as anode, and the negative electrode is called cathode. The positive electrode is called anode, the negative electrode is called cathode. These electrodes are mostly of copper, because copper is a good conductor of electricity, so these are mostly made of copper. So now moving forward to next topic, that is magnetic effects of electric current. I will make you it was discovered by heating effect is also discovered by a scientist, but it is not important for your syllabus. The important is that who discovered the magnetic effects of electric current. It was discovered by Hans Christian Ørsted. Means he discovered, he didn't invent it, he discovered that when we pass electricity through a circuit, it may show some magnetic effects. It is already there. What is discovery? Discovery is a thing which is already there, but a person notices and presented it. It is called discovery. So I will make you what does he found? He found that here you can say matchbox, compass, south, north, from a cell, positive, negative. He found that when we pass electricity through a conductor, here no, conductor is not needed. When we pass electricity through a cell, then there is a deflection shown in the needle of magnetic compass. He discovered that when we will pass an electricity through a circuit and we will wrap it around a magnetic compass, there is a deflection shown in the needle of the compass. It proved that magnetic effects of electric current means there is when electricity is passed through a conductor, it shows some magnetic changes in the property of matter. When we pass electricity through it, electricity flowed, then there is a deflection shown in the needle of the compass. The compass needle is so now it deflected, it started shaking. It proved that a conductor may show some magnetic changes when pass electricity. Now, in our chapter name, as it is chemical effects of electric current, CEI short form, we will make a circuit. How we can show chemical effects of electric current? Negative two nodes. We can say that lime water. Lime is 2. It is not lime water. Okay. Now when we will switch on this circuit, the electricity will pass through this conducting liquid, which is also known as electrolyte. When it will pass, some changes we will see. Some changes we will see in this liquid, that is, its temperature can increase. When electricity is passed through a conductor or a conducting liquid, it may show some effects in its chemical properties. That effects I am writing down: its temperature can increase, its color can change, it can form a metal substance within it. These three or more also it can form, but these three are main. When we will pass electricity through a conductor, it can show three main chemical changes, and these changes are called chemical effect means in Hindi, effect means prabhav, means when we will pass electricity, we will see some changes, and these three are the main changes. Its temperature will increase, it can change its color, it can form a metal or a residue within it. So these three are. Now moving towards the next topic of his chapter, I'm going to study about LED. It is in the box of your chapter, a small box. What is LED? LED full form is light. It is not in your book. Light emitting diode. Light emitting diode means it is like a bulb that emits, shows light. It is called light emitting diode. In a circuit, we have made this circuit of bulb, but instead of bulb we can also use here LED. LED is like this. If we want to show LED in a circuit, we can represent it by this. LED is light emitting diode. It is like a bulb, but it can conduct electricity under small electric current. If we are using bulb, it requires a high electric current, but LED requires less electric current. That's why people used to say that use LED bulb, because it conducts electricity in very less current. So very less current means that the bill of our current will be less. That's why people used to say that use LED bulb, you will get less, you have to pay less money to bill collectors. So now LED bulb consists of two wires within it. Two wires, these two. One is larger and another one is smaller. And the length is not same. One is larger and another one is smaller. The larger one consists of positive charge and the smaller one consists of negative charge. Means if we are making a circuit, then the positive charge of the cell which will be attached towards the LED bulb bigger. I have explained you that when we are making a diagram of a cell, then the bigger one is positive. Same in the case of LED, the bigger one is of positive and the smaller one is of negative. So the concept of LED is only this much. I have teach you more about it. So I can also give you a circuit where we use this LED. For example, here it is a cell, a substance. So it is a cell, electric cell. When we will pass electricity through it, it is a conductor. When we will pass electricity through it, this LED bulb will glow. I had made a conductor in which I have attached this LED bulb. Then from positive end I have placed positive and from negative I had placed negative. When we will switch on this circuit, the bulb will glow. This proves that LED bulb can glow under less electricity. Now moving towards the next topic of your chapter. There are two topics in your chapter, but three are left. So firstly I will teach you the easy one, that is potato conducting electricity. It is not a topic but it is in box, so we can make it. So here we have made a circuit in which it is cell, potato and a magnetic compass. When the circuit will complete, the electricity will flow through this potato and we can see the deflection of magnetic compass. It proves that potato conducts electricity. It potato conduct an electricity which shows magnetic effects, means it can conduct electricity. So after some time when we will see it, the color of the potato will turn into green. Here in this example we have seen two main effects. One is magnetic effects, the deflection of the magnetic compass, and another one is chemical effects, because the part of the potato which is connected to positive terminal will turn green in color, will turn green in color. Will turn green in color. So now one of the most important topic of our chapter is a circuit. I will draw it from this color only. two electrodes, and this is, I will explain you. The color is not good. Wait, here it is. I want to explain you it very deeply. So now it is done. So it is a battery. Okay, battery. Here is, we have used a wire for the passage of electricity. In this is positive terminal and this is negative terminal. Means this one is anode and this one is cathode. And these two are carbon rods. Why we have used carbon rods here? I will explain you. Carbon rods, and this is water. So this experiment will show that chemical effect of electric current, which was discovered by the scientist William Nicholson. There are various ways to prove chemical effects of electric current, magnetic effects of electric current, and heating effects. But we are going to study that how these scientists found this, how these scientists found these effects. I have taught you that about magnetic effects, that scientist Hans Christian Ørsted found it by a magnetic compass. And so this scientist William Nicholson found chemical effect of electric current by this circuit. Here he used two carbon rods. What carbon rods? You have seen cells. When the cell is over, the outer cover is of carbon, so he used that. He had completed the circuit. And when the circuit is complete, when the electricity starts flowing through the conductor, after some time he found some changes, and that changes I have taught you. But in this solution he found some changes, that there is a change of color. So where we have used water, but we know that water is a not good conductor of electricity, so the scientists also add salts within it. Now when the electricity starts flowing in it, here he see bubbles, the formation of oxygen bubbles and formation of hydrogen bubbles. Oxygen bubbles are formed from the positive terminal, and hydrogen bubbles or gas from negative terminal. These are O2 bubbles and this is H bubbles. And the formation of bubbles, it is a chemical effect of electric current. Water consists of two things, hydrogen and oxygen, and these two are separated when electricity is passed through it from positive end, because we have also studied that H2O, electricity, H plus O2 minus, no, H minus O2, wait, these bubbles is of oxygen and it is of hydrogen. We have understand that H2O means H plus O2 minus. Then you will think that the positive, we have studied that same charges repel each other and unlike charges attract each other. Here the charge is negative, but here hydrogen is formed that is of positive, and same charge will attract. So hydrogen bubbles will form from negative, and O2 is minus, means O2 bubbles will form here because same charges attract each other and unlike charges repel each other. I hope you have understand that. I will give you a quick summary of this. We have used as battery, two carbon rods, H2O mixed with salt. So now when the electric current will flow through it from the positive to negative terminal, we will see some changes. The changes are the formation of bubbles of oxygen and the formation of hydrogen. The formation of oxygen will be seen from the positive end of the battery and negative from the negative end of the battery. So here we know that same charges repel each other and unlike charges attract each other. So we know that H is of hydrogen is containing of positive charge, so it will get formed from the negative terminal of the battery, and oxygen is of negative charge, so it will be formed from the positive terminal of the battery. So now moving forward towards the last part of your chapter, that is electroplating. Electroplating electroplating So there is an experiment. That experiment I will explain you later because it's so complicated. First we will study the theory part. What is electroplating? The process of depositing a layer of metal over another metal is called electroplating. The process of depositing a layer of metal over another metal. In markets you have seen jewelry, fake jewelry, but it's giving a shiny appearance. How? Gold appearance. In this process the jewelry is of made of different matter, but at the end we are depositing another in Hindi we call parat. We are depositing another layer of metal over it to make it shiny. We will understand definition again. The process of depositing a metal over another metal is called electroplating. Electroplating in market you have seen that in marriage you have seen that some of your relatives have weared a gold shiny jewelry, but they doesn't have that financial condition to afford that. But how? In this case they have the jewelry have made the base of the jewelry is made from a different metal, but after that by through the means of electricity we deposit a thin means patla, very thin layer of another metal, that is gold or silver over it to make it shiny. So this is the concept of electroplating. So we will give you three examples where we use electroplating. The first one is in bicycles. You have seen the bicycles are shiny, but they are made of cheap metals. Then at the end we deposit by electricity, we deposit another layer of metal, that is chromium. It is very important for your exam. Chromium. The chromium is a metal which we deposit on bicycle to give it a shiny appearance. So the metal name is chromium. The second one is in jewelry. We deposit gold or silver over the substance to make it shiny. And the third one is in cans. We deposit tin. Tin is a metal. We deposit tin over electroplate tin over another iron to prevent it from rust. In tin cans you have seen cans. These cans are electroplated with tin. So what are the uses of electroplating? That is to make it shiny, to give it shiny appearance, to make it attractive, or to prevent it from rusting, we use it. And another one is to stop it from spoiling. Do you know what is rusting? Rusting means depositing a layer of hydrogen oxide over another metal. If you have seen that, when you have seen iron rod, when they are, after few years, the shiny rod converts into a reddish rods. That is by the process of rusting. So I have explained you what is electroplating, what are the substances where we use this electroplating, and why we use electroplating. Now, the most important part of this chapter, and it is also in your book, means till class 8th, the things are not explained deeply. So this in your book, it's activity 11.7, it's not explained deeply, but in class 10th, or in class 10th ICSC, or in class 10th CBSE, you will see same experiment, same activity, but it is explained very deeply. So I will explain you very deeply, so in order you will not rote learn it, you will understand it. So that activity is about electroplating of what it is. Wait, mm, wait, it is, it is very too small. Electro electroplating plating of it is electroplating of copper plate on copper in CuSO4 solution. In CuSO4 means copper sulfate solution. In copper sulfate solution, let's understand this heading. Electroplating of copper plate means we are, a copper plate is there, we have to electroplate it with copper only, means we are putting a layer of copper on a copper in CuSO4 solution. So I'll explain that. Electroplating is done in a liquid, means, so for example, here is a cell. Wait, it is not the main experiment, I am explaining you something else. So it is another experiment. Here is a cell, and it is, first one is gold plate, and another one is of copper plate, and it is in a conducting solution, that is anything, we can take vinegar. So when the circuit will start, when the electricity will flow from this liquid, from positive terminal, when this will come into this conducting liquid or electrolyte, then After some time we will see that this gold plate, this the substances of gold will slowly slowly get attached in the copper plate. Will understand? This copper plate after some time will get covered by gold on outer surface, because when we pass electricity on on a conducting liquid, on a liquid, that is, we can also take water, then the electrons will take very much energy and will take the positive end substance and will shift it. First, when the electricity will pass, this gold electrons will come in water. The gold is the chemical name of gold is Au plus, so it will get attracted toward the negative end. So this first I will explain you another time. Electricity passes towards the gold plate. The gold plate will start breaking. The electrons of the gold plate will be in the water. Gold is Au plus, means this positive electrons will get attached to this positive charge, not electron. Positive charge will get attracted towards the negative charge. So these are electrons will charges will go here in the copper plate and get attached to it. This is how electroplating is done. This is the basic principle of electroplating. We will make a circuit, we will dissolve in it a liquid, then we will pass electricity. The positive end substance will give its outer cover, shade its outer cover towards the negative terminal. So this is how electroplating is done. So coming towards the main experiment. What's the main experiment? The electroplating. So firstly, another thing, what is electrolysis? Electrolysis is also important. Electrolysis means a breaking of a material into its ions by electricity. Means we are breaking, for example, it is NaCl. We can take anything, we can take NaCl. We will break it by the means of electricity, Na plus Cl minus, or we can take H2O, H plus uh, OH minus. So the breaking of a material, the breaking of a element, not material, the breaking of a element into its ions, into its atoms by the means of electricity is called electrolysis. This experiment, if you want to understand it, you have to understand firstly the base. So I am explaining you the base. Now we are coming towards the main experiment. So here is a taking a battery. These are electrodes in a liquid. It is a plate. Okay, now it's a water, not CO is a solution. Discard it. Let us make it fully. Now here, what we are going to, this is a battery. These are electrodes. These are electrodes. This one is of positive. It is negative. It is anode and this is cathode. Now here what we are going to understand that, and it is these two both are copper plates. These two are copper plates, means a plate, a thin or a thin bar, we can also say that. These are that are made of copper plates, and this liquid or this electrolyte this liquid is CuSO4, means copper sulfate. This liquid is copper sulfate and we have dissolved it. What I told you earlier, that we have, if we want to make a liquid conducting, we add acids, base, all salts, but this CuSO4 solution is already a conducting solution. To make it more conducting, we add it here, CuSO4 plus dilute sulfuric acid, which is also called as H2SO4. Now when electricity will flow from positive to negative, then what will happen? After some time, when electricity will flow, this copper plate will, when electricity will flow through it, then this CuSO4 solution will start breaking into ions, because we have studied, when we will pass electricity through a conducting liquid, it will form electrolysis. The electrolysis process will start. The electrolysis process means the separation of an element or a solution into its ions. So it will break, the CuSO4 solution will break and will convert into ions, and these ions are Cu2 plus SO4 2 minus, these two. And we also know that this CuSO4 solution is an aqueous solution. There is a term which came, aqueous means active. Aqueous contains water. The CuSO4 solution is an aqueous solution, and a solution which is aqueous contains water. So this aqueous will also break, means it will come H plus OH minus. We will understand again. When electricity will pass through the CuSO4 solution, then this CuSO4 will start breaking. This CuSO4 is an aqueous solution, means it contains water. Then CuSO4 will break into into ions. It will form electrolysis, that is Cu2 plus SO4 minus. H2O will also break, that is H plus OH minus. Now here now in this solution we contains a two positive and two negative. So we have all earlier studied that, I have taught you that positive same charges repel, unlike charges attract. So this solution had break down. So this positive terminal will attract negative, that is SO4 minus and OH minus. Now this negative terminal will attract positive charges, that is Cu2 plus and H plus. Cu2 plus and H plus. Now wait. Now what will happen? These negative charge will get attracted with the positive charge, and this the positive charge will get attracted towards the negative charge. Means SO4 will SO4 and OH minus will migrate. They will migrate with towards this plate. Both will migrate, but the main thing is that no one will get attracted there. Both will migrate, but none SO4 non OH will get attached there. Then what will attach? Because there in this positive charge no other ion will get attracted there, but in the negative charge there is Cu2 plus and O3 minus. I will explain you the reason why this positive charge, these both will migrate. This negative charge doesn't get attracted with the positive charge. They both will migrate but will not get dissolved. Why? Because I will explain you now. It is anode, that is Cu minus 2 electrons is Cu2 plus. But in the negative side what there is, there is copper and hydrogen, that is Cu2 plus 2 electrons, which is Cu. Now we are going to understand this. What does it mean? In the positive side, firstly we will understand negative. In the negative side, there are copper. It is not positive. Wait. Yeah, it is 2 only. This copper, the 2 atoms of copper, 2 molecules of copper plus 2 electrons will form copper. Means it is 2 in upside of copper, and here is 2. Then these 2 will cancel out. This positive and negative will cancel out, remaining Cu. This also means that 2 atoms of copper, and this also means that two atoms of electrons. Then this 2 is of positive and this is of negative. When they both here, this both will migrate upside but will leave Cu. When they both will migrate, they both will form copper. Means a layer of copper will get deposited over here, because there are different, we separate these ions. The COSO4 solution gets separated into 4 ions, and these 2 ions are of, one is of in this part and one is of this part. So these 2 ions will also get mixed up within it. So these, in the negative terminal, the copper, 2 atoms of copper and 2 atoms of electrons will form only a single copper. But in the positive side, there is copper, simple copper minus 2 electrons, Why minus 2 electrons? Because it is containing of a charge of 2. Minus 2 electrons, that will lead to Cu plus 2 atoms. I know that it is very difficult to understand, but and the symbol of copper is Cu. Here in this part, copper is going upside. Copper is going upside, and here copper is remaining here. So means after in this reaction, what are the outcomes? The outcome is that there will be no change in color, because there will be no change in color because the concentration of ions is same. If two are going upside, then two is coming backwards also, and the layer of copper is forming in the negative side. I will explain you this again. First, till here you have explained that you have understood that CuSO4 solution breaks into four ions that are Cu2 plus, SO4 2 minus, H2 H plus, and OH minus. And this also you have understand that negative and positive attracts. So this negative side, this copper and hydrogen, this copper is Cu2 plus. This Cu2 plus, this Cu2 plus, this negative side, Cu2 plus will migrate upwards. This Cu2 plus will migrate upwards and will leave a layer around it. Negative side, understanding of negative side is easy, that when it is breaked into two and when it get attract towards the negative side, the positive Cu plus and H plus, this Cu2 plus, this Cu2 plus and H plus will migrate upwards, but only Cu2 plus will get attached there. So it attached here, it attached, leaving a layer. The negative side is done. Now coming towards the positive side. The positive sides, there are two ions, that is SO4 2 minus and OH minus. They both will migrate. They both will migrate upwards, but none will go there. Why? Because copper anode will lose its electrons firstly. What does it means? What I said? Copper electrons will lose. Copper will lose its electrons firstly. When the process of electrolysis will start, then this copper plate, as you know that electricity is transferred from positive terminal to negative. So at the beginning of this electrolysis, this copper will lose its electrons. Means copper electrons means Cu2 minus. This copper will lose its electrons firstly, and here, so this both will migrate. At first, what will happen? The copper will lose its electrons. Then this Cu2 plus will Cu2 plus not SO4 2 minus will go upwards, and OH will also go upwards, but none will deposit over there. Here what happens? This, and you have understood this much. Negative side also you have understood that Cu plus and H plus will get attracted towards the negative side, then both will migrate, but Cu2 plus will only leave a layer. In the positive side, there were two ions, SO4 2 minus and OH minus. The SO4 2 minus and OH minus, they both will go upwards, but none will deposit. Why? Because this copper plate will lose its electrons firstly, will lose its electrons, and its electrons. And what are its electrons? Cu2 plus. As you have understood this much, now I said that there will be no change in color in this electrolysis, because as the cu2 plus is going upside and in the negative side cu2 plus is going in the negative side, in the see in the negative side cu2 plus is going over this plate. So in the positive side this co2 plus is going downside, because this copper is losing its electrons. That's why the color will be same. So this is for the chapter. By I know that this chapter is a little bit complicated from all other chapter of class 8th, because it contains of some chemistry that is you have to understand the basics of chemistry, but you will understand the basics of chemistry in class 9th. I have taught you the basics also, then I explained you deeply. That's why my lectures are more longer than all other teachers on the YouTube. And in this channel you will study quality education. The other for big institutions like PW, they are only giving 30 minutes lecture. How this chapter can be completed in 30 minutes? I have given you 1 hour 20 minutes long lecture, in which I have explained you every A to Z thing. So this is for the chapter. Please like and subscribe my chapter. I have made it by very much hard work. So that's it. Bye.